So welcome you all in today's lecture. The lecture topic is nitrines, benzynes and their generation, structure and reactions. So in this, these are also an intermediate, and these intermediates has an great application during the course of organic reactions. So here we will go in details in terms of like as we said, nitrines and generation, their structure and reaction of nitrines. So after that we'll also discuss about benzynes, their normal reactions, their structures, generation and possible reactions. So this is are the contents of the lectures. So species. So now these are the new if we see about now, coming to the main discussion, which is we are going to start from the nitrines. So these are the neutral reaction intermediate, when the central nitrogen atoms is electron deficient and has a sextet of electron. It means there are 6 electrons in the nitrogen species. So you can see here 2, 2, 4 and 1 is having the covalent bond. So this is the typical structure of this is the nitrine, you can see. So here it is sp2 hybridized and planar in shape. So this, if you look at here, so there is in sp2 iminium ion and in ammonium ion. So how does the nitrogen is there? So here you can see in case of iminium ion, and here you can say in case of uh, this is tetravalent versus 8 valence electrons. So here if you see in a divalent ions with 6 valence electrons, so here you can see in sp azacation and in sp2 azacations, and this is the nitrine species. So this is univalent nitrogen and 6 valence electrons. So if you can count the electron number, so this is a 6 electrons. So it is like a neutral. There is as such there is no charge, but here if you say these are the cationic nitrogen species, all are having plus charge, so these are the cations. So here this is also cation, and also their specific, if we talk about their number of electrons, so you can count the number. And but here if we are talking as the nitrine intermediate, so this is the neutral, you can say the neutral reaction intermediate, so which is having also very important role in during the chemical reaction. So if you see as we discussed in the previous lecture, carbines, these are also generated by protolytic thermal or base catalyzed alpha elimination reaction, as we seen in case of carbene synthesis or carbene formation. So similarly these can be formed with the help of protolytic or thermal or base catalyzed alpha elimination reaction. So here if you see, this is the alpha elimination of this nitrogen. This is the alpha group with respect to alpha, beta, gamma, like that. In case of so here this acyl nitrine has been formed. So this nitrogen is having the 6 valence electron, and it will produce a neutral species which is nitrogen. So alkyl halides also can, you can in presence of photolysis, you can produce the alkyl nitrine. So these species can be formed with the help of thermal or base catalyzed alpha elimination reaction can be synthesized. So now coming to nitrine generation with the another way of producing them. So you can, like the base OH is reacting in with the N-bromoamides. So in N-bromoamides, you can see here it is forming acyl nitrines, and hydrogen and bromides ion is being replaced. So by the reduction of nitro compounds with trialkyl phosphides also will give you the nitrine species, and these nitrine species which will further, which is the intermediate, will make a phenyl, like in case of this phenyl nitrine here. So this species will also formed by the, if you are starting with trialkyl phosphite. So this is the trialkyl. In case of this, the ethoxy group, this is O, ET, tri 3 group is there. So a reaction, if you see the reaction, how does these species reacts? So if you see here, so singlet nitrene undergo a, a sigma insertion to give secondary amines. For example, here you can see, these electrons could be in a singlet nitrene, like in case of carbene we have seen, or triplet nitrene, already we discussed in the previous lecture. So similarly, this nitrene can, these electrons, these two free electrons, which is in the species, can exist either in a singlet form or either in a triplet form. So here in this molecules, alpha insertion into a carbon hydrogen bond, here you can say carbon hydrogen bond. So this is, there is a insertion reaction. So this undergo, this kind of rearrangement product, and then finally this makes a secondary amines. So by this way, these are having a very great role during to synthesize such kind of ring structure, which is having very important role to form the higher complex organic molecules, which is having great importance in the to the formation of various kind of pharmaceutical products and many other alkaloids, steroids synthesis. So these kind of intermediate is having a very great role during the formation of this kind of higher species or higher molecules. So now you can see here there are many more reactions you will find in case of in a nitrene. So pi insertion of nitrene into a carbon double bond carbon will gives aziridines. So here you can say in a singlet carbenes, in case of a alkenes, has been reacted with the alkenes. So this is forming this species. You can see the cyclic species. However, if you see in terms of stereochemistry, so there will be the strain, high strain will be there in a smaller rings as far as the stereochemical aspect. So here acyl nitrines undergo skeletal rearrangement to give alkyl isocyanates, and this rearrangement is involving Curtius and Hofmann rearrangement as well. So when we will discuss these kind of reactions, so you will see these reaction goes through the nitrene formation, and these reaction are, as I said, having a very great role. So without the formation of these intermediate, these reaction will not carry forward. So these are having a very crucial role during the organic synthesis to synthesize various industrially important chemicals. So they are having a very significant role in that aspects. Now triplet nitrene, if you, as far as, because singlet nitrene will be that is will be the neutral, the cancel out and diamagnetic. And here if you see the triplet nitrene, because this can be having a special radical, free radical in a different orbitals. So this singlet nitrines like carbenes, you can go with the electron EPR electron spin resonance spectroscopy or ESR spectroscopy. So with the help of that or electron resonance spectroscopic methods can be very useful for the detection purpose, as far as the detection of these kind of species, these kind of nitrene species, means how to detect it during the course of reaction. So this can be easily detected with these techniques, as we have seen in detection method for the carbene. So now you can have some idea here, nitronium ion. So nitronium ion is also called as amynylium ion, or nitrogen with both an electron ion, a lone pair and a positive charge, and with two substance R2N plus sp3 hybridized and non-linear or bent structure. So here you can see the nitronium ions structure like this, and again you can see here N plus and N here triplet nitronium ions, and this is the singlet nitronium ion. Triplet means they are in having a separate or different orbitals having a same spin, but here this will be nullify the spin of the one electron by the another one. So this kind of structure can be seen for the nitronium ions, which is also is a great relevance. So as far as once we are talking about the their stability, so the type of ligand attached, or example, if aromatic ring is attached to the nitrogen, they are called aryl nitrinium ions. So depending upon the which kind of rings they are attached, so similarly their name is designated. Halo and alkyl nitrinium ions if halo and alkyl groups are attached to the nitrogen. So aryl nitrinium ions are characterized by delocalization of the positive charge on the nitrogen into the aromatic ring. It makes a ring susceptible to the nucleophilic attack. So that makes rings too will get very susceptible for the to react with the another reagents. So these intermediate is plays a very important role. If any species, if any organic substrate which is not reactive as such, but after the insertion of this kind of special group is there, and that creates these kind of special active sites on the atoms or molecules by which you can react those species with the another substrate or another reactant or reagents, so that the new product formation possibility will rise up. So that is having a very great role again in a organic synthesis. And because this is organic synthesis is very vast area of study, it is not only restricted only in a, like a medicines, pharmaceuticals, various type of chemicals, industrially important chemicals, reagents, isomer, stereoisomers, and those enantiomers, which is having very great role during the synthesis of medicine, as well as new drugs, drug discovery as well. So these are the intermediate which is having their great concern. So their knowledge is required once you are become a good organic chemist. So here we can also see here like nitronium structure, nitronium ions. So here you can see double bonded nitrogen is double bonded to one atom, hence they are called vinylidene nitrinium ion. So depending upon the type of in which this nitrogen is attached or bonded, like in case of vinylidene nitronium ion, so vinylidene, if it is vinylene type of fragment is there, so if there is this kind of species is forming, so accordingly their name will be set like that. So their name will come to according to that. This has to keep in mind. Once you if it is in a benzene ring, then aryl, and if it is like in this kind of vinylene fragment, if it is this nitronium ion is being forming, so accordingly you can have the name, you can call them like vinylidene nitronium ion. So by this way you can designate the name. So now generation and fate of the reaction, because there are after generating this kind of species, this kind of nitrinium ions, so you will see that there is they will go with a different kind of reaction, protonation. By here if you see an alkyl anthracium on photolysis produce primary nitronium ion by protonation of the nitrogen, followed by heterolysis of NO bond. So if you heterolysis means it is not similar, homolytic bond and heterolytic bond, I hope you all might be aware of that. If the sharing electron is distributed to only one, or if the one of the atoms took the sharing electrons, then that will called as a heterolytic fission. And if the distribution of the the distribution of the sharing electron goes equally to each of the atoms, so in that case they will produce radical. So here it is very important to see that what kind of fission is there. So in case of an alkyl anthraneum ion, it is making aryl nitrenium ions. So by this way you can generate and the particular reaction in a reaction, so that the will decide the fate of a reaction as well. So here if you see the reaction, photolysis of azides to form nitrene followed by protonation in presence of weakly acidic solution, it gives a nitrenium ions. Here you can see aryl azides, nitrene, singlet nitrene, and further it will give you the nitrenium ion. So because these are interrelated to each other, so nitrene is formed by the photolysis, and further at low pH it converts into the nitrenium ion. So these are having a very close relations, close during the course of reaction. So this is we have to be idea about this is required once we study the nitrene. So electrochemical oxidation of amines yield nitrenium ions, but principal disadvantage of this method is formation of polymer. So because you can synthesize by electrochemical oxidation of amines, it can gives you the nitrenium ion, but there is certain disadvantages due to this, because this can make say a polymer, so you will not get exactly what you want at the end of the reaction. So here amines, oxidant is here, aromatic sulfur oxide. So this makes this intermediate, and then finally it makes a nitronium or nitrenium ion. So there are many more reactions you can see, and you can check here, like from this N-amino pyridinium ion. So it is making this kind of different nitrenium ion. Again, you can synthesize from such kind of molecules, and it also leads to a cyclic, it will leave the cyclic ring structure intact then, and it will remove this nitronium ion. So by this way these can be formed of, and there is also singlet or triplet species of nitronium ion can be formed during the course of reaction once you are synthesizing this kind of products. So now coming to another which is very important also is benzene. So highly reactive intermediate, generally during the course of certain, it is this is very highly reactive species, and generally formed during the course of certain reactions. So they have not been isolated. No, these are generated in certain aromatic compound in case of strong base conditions. So means in if you have a aromatics with like in chlorobenzene and methyl toluene, in case of toluene as well, if that is substituted at ortho position, so by reacting some specific base, like in case of toluene, and if it is substituted at ortho position with particular groups, so sodamide can be used to make a benzene intermediate. So these benzene intermediate is having, if you see here, is a like a one bond, but this is not exactly as the triple bond which is in case of straight chain hydrocarbon. So this is this is the actual structure you can see in case of the benzenes. So benzene intermediate can be formed up by by generating the certain reactions with the help of very high conditions, like high concentrated base and with certain high pressure. So you can make it in a lab as well, but these are very unstable species, and very difficult to isolate, and they cannot be easily, no, not such way to isolate them. So these are the reaction. If you see in case of benzynes here, this is like in case of bromobenzene, it reacts with sodamide. So this makes a benzyne intermediate, and this benzyne intermediate reacts with sodamide further if you are reacting it. So this makes a, amino compounds, amino groups in presence of ammonia. It makes a amino benzene, and benzenes plus sodium bromides and ammonia if you are reacting it with. So these are, biphenylene dimer of the benzene has been formed. So here two benzene rings get attached, and so the biphenyl groups has been formed, and it is a dimer of the benzene. So similarly, if you see here, there are another reaction in this way. You can check here. In case of like here, we had put in a one single reaction where the benzene is being formed, and further, if you are reacting with a certain other reagents, so this makes a different products. So the benzene formation, and simultaneously it is making the different kind of products. So there are many more reactions. In case of no, you can react with the base as well, like sodium hydroxide has strong sodium, concentrated solution of that. So further you can synthesize this. Mm, Here, if you see the stability, so benzene is an example of arine, means triple bond compound, and triple bond cyclic, because it's the aromatics. So this is no ordinary triple bond, as the second pi interaction results from a weak interaction of sp2 hybridized orbital lying in the plane of the ring. So as I said, this is not as the normal triple bond as you had seen in case of alkenes, in case of simple hydrocarbon. So this is having another, importance here. So weak interaction of sp2 hybridized orbital lying in plane of the ring. So the triple bond is non-linear due to the constraint of the sixth member ring. Benzene is, strained and highly reactive species. It is having at the place of where the triple bond is there, there is strong, strain is there, because they are having the orbitals which is, like this kind of interactions, which makes the molecules more, unstable, and having more, instability. It creates a more instability in the species. So overall, if you see this is having a stability. As far as stability, this is having, highly unstable and highly reactive species. So if you see from the overall discussion from the today this lecture about the nitrene and benzynes, we have seen that in case of nitrenes, because that is a like a neutral species, but in a certain condition, this is at even at a different pH, it can convert into the nitroniamines. So these nitrenes is having very great relations, very great importance in a various kind of synthesis process, in many more reactions. Their generation, we can generate them from, or we can produce them from the different starting materials with the help of different starting reagents and different starting, reaction, and these are also formed during the course of various kind of reaction intermediate. Once you will see the reaction during the course of reaction, in case of very lengthy reaction, if it is there in many multiple step reaction is there, so you can see there are nitrene formation is very common in organic synthesis. Many name reaction also goes with the nitrene formation, and their structure we have seen, because this is having the total 6 electron. And in case of nitrogen, if you are as far as concern of nitrogen here, so they are going through a different reaction. We also studied that. uh, and benzene, in case of benzenes, because this is a very unstable species, having a triple bond in the aromatic rings, they can be synthesized with the help of, you know, with a strong base in specific uh, standard conditions, and then they can also, during after the formation of the intermediate, they can react with the different kind of reagents, and they makes a another product of interest. So by this way, you can see how can we make a, a different kind of product with the help of these intermediates. So these intermediates like nitrenes and benzynes, and in case of nitrene there is also nitroniamine is also, because that is related to that, so is also having a great importance during the course of various reaction. So these reactions are very important as far as the organic synthesis. So if you see that these all, after overall discussion, these are the references and source from where this contents has been, prepared, and can be taken from there. Also and taken from the help of these internet resources, and books has been also referred. So this material has presented here and prepared only for lecture purpose, has been from the books and internet website, and this instruction material is only for the instructional purpose, and having no other use, or no other intention of use. So thank you for listening this and watching this video. Thank you so much.